In this session, we'll see about loop functions. So we'll explain you what is looping, and here we are seeing about looping on the command line of R programming. So here we know about for loops, while loops, and all. So if there are any simple ways to use those, in the command line, it will be really useful as a programmer. So writing for while loops is useful when programming, but not particularly easy when working interactively on the command line. So there are some functions which implement looping to make life easier. For example, like in R programming especially, you have functions called lapply, sapply, apply, tapply, and mapply. So what are these basic functions? What do these basic functions do? We have lapply. What lapply does is it loops over a list and evaluates a function and each of the element. And what is sapply? Same as lapply, it loops over a list and evaluate a function on each element, but it tries to simplify the result. So I'll give you examples and it will give you a clear-cut idea of what lapply and sapply are. So what is apply? So apply is a function over the margins of an array, and tapply is apply functions over subsets of a mapply, multivariate version of lapply. So these are the basic for apply functions, looping functions. So an auxiliary function split is also useful, particularly in conjunction with lapply. So I'll tell you about this function in detail in the next session. This function is called split, and this does the it's particularly works in conjunction with lapply. So what is lapply? So lapply, it basically takes three arguments: a list x, a function, or the name of the function, fun, and other arguments via its ellipsis argument. If x is not a list, it will be coerced to a list using as dot list. So we have seen about the coercion process earlier. So if x is not a list, it will be coerced to a list using as dot list. So now we'll see the what is the functional attributes of lapply. So lapply, the function of x comma fun comma ellipsis. So fun is nothing but match dot fun of fun. It matches with the function which is being passed into, and if not dot is vector of x or is dot object of x. So if the argument passed is not a list, then the conversion happens in the next step, where you have x equal to as dot list of x. So when it is not a list, it is converted into a list. And dot internal of lapply comma x comma function. This is where the function is being called. So this actual looping, it happens internally in C code, but you don't have to worry about that. Lapply, using lapply will solve you that purpose. So what is the output of lapply? So lapply, it always returns a list regardless of the class of the input. Let's say you have a list x of list a 1 is 1 to 5, b r norm of term random normal variables of 10. So when you apply lapply, so you'll get x comma mean. So it will apply to every list that is being passed to. For example, it will you are passing two lists, a equal to 1 to 5, b equal to 10 variables. It will compute the mean for each of the elements of x. We will see this in our R programming module. So here we'll see have a list of a equal to 1 to 5 comma r norm b equal to r norm of 10. Now the x is created. If you print x, you will see 1 2 3 4 5 and random variables with mean equal to 0. Now what if I apply lapply function to this, and when I pass x and I want to calculate the mean for each of the elements of x. Now this will give me a which is the first element, the mean of 1 2 3 4 5 which is 3, and mean of these 10 elements which is 0.584092. So this is the use of lapply. So when you have like multiple elements in the list, for each of the elements is this lapply works as a for loop and performs the function mean in each of the elements. So now we have got the same answer. The answer is different here because the random variables might be different in the earlier cases. Again, we have a list of 1 to 4 and r norm of 10, r norm of 20, comma mean equal to 1, r norm of 100, comma mean equal to 5. When you apply the lapply of x comma mean here, for each of the elements, again the function is applied and you will get the mean for each of the variables. So this is the use of lapply. So you can run the for loop in the command line itself. Again, we are seeing one more example for lapply where you are trying to create a uniform distribution for the values inside x. We have x equal to 1 to 4 and you are applying the function or uniform distribution of lapply x comma or unif. So with this function you'll get the random distribution, uniform distribution for the values 1 to 4. You can see the value is 0.262 ranging from 0.71. So this is how the lapply function works. Again, we will see one more example. So where we have x equal to 1 to 4. Maybe we can see this example in our module. So here we are trying to create a uniform distribution where we'll have minimum is 0 and maximum equal to 10. So it will not start from the negative. The minimum starts from 0 only. So let's assume we have x equal to 1 to 4 and now when you apply the lapply function x comma r unif, the function name, and I'm passing through the ellipsis parameters where min equal to 0 comma max equal to 10. Now when I run this, you will get the corresponding values. Every value will be as a random distribution between 0 to 10. Now moving on, lapply and friends they make heavy use of anonymous functions. So when you have you can create multiple functions, and when you want the function to run over a matrix or each and every element of the list, it will run. Let's say I'm creating a matrix where a list we have the basic elements of the list as two matrices. The first is a matrix of 1 to 4 and 2 comma 2. The number of rows is 2, number of columns is 2, and here we create a matrix where 1 to 6, the number of rows is 3 and the number of columns is 2. So when I create this, you will find the matrix to be 1 2 3 4 and 1 2 3 4 5 6. So what do you want to do with this lapply? So I'm I'm creating an anonymous function which extracts only the first column of the table of the matrix. So I'm creating a function called function of ELT, and this ELT function gives the first column comma 1, which means the row is empty and the column is 1. So if I take this column, this 1 2 and 1 2 3, I'm trying to extract this alone from the data. So this is an anonymous function for extracting the first column for each matrix. So I'm extracting 1 2 and 1 2 3 using the lapply function, and I'm defining the function in the within the lapply function itself. So moving on, we are coming to the part of sapply. So sapply, what it does, it will try to simplify the result of lapply if possible. So what do you basically mean by simplification? So let's say lapply normally returns a list. So if the result is a list where every element is length 1, so what is the point of having a list when you have all elements of length 1? So then a simple vector is sufficient. So that is what lapply basically does. So if the result is a list where every element is length 1, then a vector is returned. So if the result is a list where every element is a vector of the same length, so it is greater than 1, then a matrix is returned. So this sapply is a simplification function which works on the lapply values. So if it cannot figure things out, again normally as a list is returned. Moving on, we are seeing an example here. This example I think we saw earlier in the examples itself. So we have a list created as called X, which has the values a 1 to 4 and b random normal variables of 10, c random normal variables of 20 and the mean is 1, and d equal to random normal variables of 100 comma 5. So when I apply the lapply x comma mean, you'll find 2.5, random normal variable 10, 20 comma 1. About all these variables you'll be given the mean function. So what does so the now as you can see, the result is a list. You'll have $a, $b, $c, $d, each points to a particular mean value, and this forms a, we have only one element per inside the element, so that's the reason it's giving us a list, because we are using a. Now what if I use sapply function? Now if I use sapply of x comma mean, I'll get a single vector wherein I have the values of 2.5, 0.06 for each of the elements in the list. So now warning message is displayed in main.default of x. Argument is not numeric or logical, and returning NA. Now we'll see about the apply